Okay, now we're going to start talking about inverses. So if you have a function, f of x, the inverse of this function, this is what the notation would look like. F to the raised negative 1 of x. Another notation, see, remember how f of x means the same thing as y? Well, the inverse would be y to the raised negative 1 of x. And graphically, let me show you graphically what a function inverse might look like. So the original function is in blue. So f of x, I should have done that in blue. F of x is equal to x cubed. And then the red function is the inverse. Well, look at, that's the cube root of x, right? The inverse of cubing is cube rooting. Graphically, look at what's happening. You have this at a 45-degree angle running through the origin. You have this dotted line, this invisible. We're going to pretend it's invisible. And then look at what happens. If I could draw it perfectly, those two, if that were on a piece of paper and you fold it over, these would fold up on itself. And then this curve right here would fold up. Let me make this a little bit smaller. This curve would fold up on this curve. And then this line right here would fold up on this line right here. So graphically, you can tell if functions are inverses, because at a 45-degree angle, either at the origin at some other point, the graphs will fold up on each other. Oh, I already did have them written down. All right. So here is the process, the steps to finding an inverse. If you are given an f of x equals, I don't know, stuff, you first rewrite f of x to y, then you're going to swap the y's and the x's. So instead of this saying, instead of this saying y is equal, you're going to swap the x's and the y's, and then wherever there were x's here, you're going to put y's there, and then you're going to get the y by itself, and now there will be stuff over here, and when y is completely by itself, it will now be the inverse of what this started out to be. So then you just write the raised negative 1. Let's go ahead and get started, and I'll tell you what I mean. So first thing we're going to do is rewrite g of x as y is equal. That's all I did. The next step, we're going to swap the x's and the y's. So this y and this x swap. Not the numbers attached, just the variables x and y. And now our objective is to get the y by itself. Well, the first thing that you're going to do is we're going to add this 1 to both sides. And then how do we get rid of an attached multiplying 1/4? You multiply by the reciprocal, 4, or 4 over 1. Those cancel. When you multiply this side, since there's a plus there, could be a minus, you have to put a parentheses around it, and now you have to multiply 4 by each thing. And then you're going to do the distributive. So 4 times x is 4x. 4 times 1 is 4. And now because the y is by itself, it's y to the raised negative 1. Since it originally started out as g of x, probably writing it as g to the raised negative 1, just like that. All right, let's do another one. Ooh, you've got a 5th root. Well, same thing. You're going to rewrite as y is equal. You're going to swap the x's and the y's. The x is here, y is here. Now that you've done that, you're going to subtract 2 on both sides. You always get rid of the unattached things first. So that's what we did. And once you've done that, and that cancels, well, I think, there we go. So that's canceled now on this side. Well, what is the undoing of a fifth root? Taking something to the fifth power. Remember, the entire parentheses gets the fifth power. And the fifth power of something to the fifth root, that will cancel. Whoops. And now you're left with y subtract 3. So now you're just going to add 3 to both sides. And I think that's, I'm sure, what I did in the last step. Yeah, we added 3. So the 3's cancel. And then what you're left with is the expression x subtract 5 to the fifth power plus 3 is equal to the inverse of y, which is also the inverse of g of x. All right, let's keep going. Ooh, these rational ones, you have to be really careful with these, but it's the same process. You rewrite as y is equal. All right, so here's our y here. Notice the negative sign stays with the x. That doesn't become negative y over here. And then the first thing we're going to do is add a 1 to both sides. I guess there's no reason for me to hold on to that. All right. Oh, I just rewrote everything. So we're going to add 1. That cancels. Add 1. And then now we have a fraction. So I'm going to write that over 1. I am getting ahead of myself. I apologize. So the 1's cancel, and now I'm going to put that over 1. And remember what I said, when you have a fraction equal to fraction, but the variable we're trying to solve is in the denominator, you can flip both sides. And I think right there I just rewrote it. That, now I went ahead and flipped both sides. Right here, I multiplied both sides by 2. Well, 2 times 1 is 2. Oh, look at what I have here. Actually, what I did, so let me undo that, because I saved a step. Notice there's a 2 here, but eventually we're going to want, sorry, my other video just produced. Let's see if oh no, I just made another. Okay, so yeah, multiplied both sides by 2. There should have been a negative y still there. So now we're going to add y to both sides, or add 1 to both sides. And then I've got this, that was a positive 2 right there. Then I'm going to get rid of this negative y by changing all the signs. Well, when I change that, because that's like multiplying by negative 1. So this was a positive. I can either put the negative sign here, this is best practice, or you can put the negative sign there. So what you end up with is negative 2 over the expression x plus 1 is equal to y to the raised negative 1, the inverse, or g to the raised negative 1 of x. All right. Okay, now we're going to do the general sketch. So I'm going to go ahead and end this one, and then we'll talk about sketching.